For anyone that has tried this, again, the answers, the letters, the answer key is at the very last part of this. But now we're going to go over what is called the strategy for getting these answers. And some are true, false. Now, is a negative value greater than a positive value? No, that's not true. So that is false. Write the set in roster form or roster notation. And this is in set builder notation. X is such that x is an integer greater than -6. Well, if it's greater than -6, it will start with a -5 going to the right. So, looking at these, and this ellipsis here indicates it's going on to positive infinity here, so this is B. Now, for example 3, and you're going to get some like this, is to substitute these values into this. So let's clear it up. And where there's a y, we put a 4. So 4 minus 6. And then our x is a -3. So put that in parentheses. And then 2x, 2 times -3. And then plus x is a -3, and y we said was 4. So the idea of putting your variable in a parenthesis is a really good idea, because now when you go to simplify, you're going to do this parenthesis, this multiplication first. This is an 18. 18 plus 4 is 22 on top. And then 2 times a -3 is a -6 here on the bottom. There we go. And this is going to be plus, this is going to be a -12. So a negative and a negative add up to a -18. So let's write that in the bottom here. Oh, let me pause here and get that set up again. So that gives us then a 22 over -18, which reduces to a -11/9, which is, in this case, C. Let me clear it up so you can see it. And you can always go back. All right, let's raise it up a little. Now, this next one is not one that we featured, but we could give it a quick review here. When we have a -2, and we add its opposite to it, which is a +2, the result is 0. This is called the additive inverse property. Now, the additive identity property is if you have 2 and add a 0 to it, it's still 2. You can add 0 to anything and don't change its value. And then the multiplicative identity property is you can multiply anything by 1, and that doesn't change its value. And we use that a lot when we're changing fractions to common denominators, where if we have something like 2/3 plus 1/5, and we want to add those, in order to add them, we must have a common denominator, which would be, in this case, a 15. And then to get this fraction to have a denominator of 15, we can multiply it by a 1, but in a form that will make our denominator 15, which is going to be 5 over 5. And this one, to make it a 15, we're going to use the 1 here in the form of 3 over 3. So this then would become a 10, this would become a 3, and our final answer would be 13/15. Just to give you a little background on some of these. Now another one, the associative property, is that if we have a series of, let's say, add-ins, this will be, let's say, let me give numbers here. Oh, we could use letters too. D, mess that up. Let's try to get A plus B plus C equals A plus B plus C. Now, as we look at these are identical. Now, the associative property comes in when we say we could put a parenthesis around those, add these two first, or we could put a parenthesis around these last two. The order is the same. Now, the other one that we haven't covered is the commutative property, which says that if we have A plus B, that is equal to B plus A. That is, we can reverse the order and it's still valid. So these are some rules that we use in basic math to give us the right to do various things that we do when we calculate. All right, number 5, we want to simplify this. And when we have a negative exponent, basically all that means is we put a value in the numerator, bring this down to a negative 4a, and then the sign of our exponent changes as it crosses that division bar. So we're saying now just square this. Well, squaring a negative 4 times negative 4 gives us 16, and then a times a is a squared. So this would be our answer. Now here's some background for Chapter 2, which is equations. We're asked here to distribute to get rid of parentheses. So this becomes 9y plus 54, and then your y, and then distribute this. Collect like terms, we get 10y plus 54 equals 10y plus 10. Now, for something like this, as you look at it, if you subtract 10y from this side and 10y from this side, the y's just disappear, and you get 54 equals 10. Is that true? And the answer is no. Well, when it's not true, we say it is an empty set, or there is no solution. Probably on our papers it'll say no solution. Other ways of indicating an empty set was braces with nothing in it, or a circle with a slash through it. Okay, let's go on. Now, in this next one, they want us to solve this equation. And let me write it here. 5x minus 2y equals 5. we want to solve it for the letter y. Remember, this is in standard form, so I would bring the negative 2y over to this side where it becomes a positive 2y. Bring the 5 over here. Now it becomes a negative 5, and this is 5x. Now we divide everything by 2. And then I would cancel out these 2's, and I would get y equals 5/2 x minus 5/2. Now, the way they've said it is they put it all over the common 2 here. So it looks like it would be letter C if I put my numerator over the common 2. Remember, we would like it this way, because this way it's in slope-intercept form. Y equals mx plus b. All right, let's go on. Here they're asking us to find 16% of 50. Well, 16% you would convert to a decimal fraction of 50, which is just multiplication, equals your number. So I put that into my calculator here, and I go 0.16 times 50, and I get 8, which is letter A. All right, let's go on again. Let's go back to my red color here. So we read this over. It's a number of soda pop cans sold on campus here. Different temperature days, and they want us to make a scatter diagram of this. Now, we didn't do this type of thing, but it's a good little mathematical exercise. What you would do is look at your temperature here, and it goes from 70 to 90 here, and then the number of cans sold, and you want to put that data here. So how would you set that up? Well, after looking at your data, you could, on this x-axis, set up your temperature. And I think we lost something there. Let's see here. Yes. Set up your temperature, so this would be T. And then here, this would be the number of cans. And I looked there, studied my data, and it's 300 to 500 or so. And then I will say 70 here. It was 325, so about like that. And then 75, 350, about there. 80, I have 440, which is about there. And then 85, I have 470. And 90, I have 575. So, again, depending if you had to make your own graph, you're not going to have one like this, but this would be background and then a way to express data. This is referred to as a scatter diagram. Okay, let's go on. Okay, now this is something for sure we're going to have as we look at it, and we want to graph it. Now, in this case, we have graphs to choose from, but if we were going to do this ourselves and then get an idea how to solve it, I would solve for y. I would go 2y, transpose this over to the other side as a 16x, positive 16x, minus 18. And now divide everything by 2. I would get y equals, this is going to be 8x, and this is going to be a negative 9. So again, if we put this into our lab system, the graph would form, but in older days we had to actually solve it. So this would be our y-intercept here at negative 9, and our slope is 8 over 1, so we would go over 1, up 8. So our line then would look something like this, and maybe a little bit more. So when we went to match it, let's see what graph we could choose here. And it looks like letter C here. That's the closest to it. Okay, that was one that was a good one for our general graphing technique here. All right, here's another one that we might look at. Now, as a general review, and we did review some of these in other lessons, we said if an equation looks like this, y equals negative 4, that's in the form y equals b, where b is our y-intercept. So we're going to just put a line, and these are horizontal through. Let's see if we got a nice line here. Negative 4. And remember, it goes on to infinity. So a, as we see here, would be y, get a pen going, y equals 4. This one is x equals negative 4. It's the vertical line going through negative 4. And we'll move it up a little. And this one is negative slope and not a horizontal line. So our answer here is letter D. All right, here's one that is of... All right, now for this one, we want to put a line through this point with this slope, and we want it to end up in standard form. So let's do it here. Now we could use point slope, which is y minus y sub 1 equals m times x minus x sub 1. And our slope is a negative 4. Our x is a negative 5, so the opposite of a negative 5 makes it a positive 5. And our y is 3, so y minus 3. Now, keep in mind, sometimes they might ask you, looking at this equation, what is the slope and what is your x and y coordinates? Well, remember, when it's in point slope form, it's the opposite of this. So here it's a positive 5, but it was actually a negative 5 up here. And here it's a negative 3, but it was actually a positive 3. So putting it into the formula because of these negatives here, change the sign. So then we get y minus 3 equals negative 4x, negative 20. Just distributing this. Now we get y equals, transpose the 3. On this side it becomes a positive, so this is a negative 17. Then we take this term, bring it over to this side, and we get then a positive 4 over there. Let me just bring that over there so we could save a little space here. And there we have it in standard form. So we just have to match it up here. Well, this is an interesting situation where if you look at the answer I got, and if you look at the answers in the multiple choice, none of them are there. But if you look at example C, our A term here is negative, this is negative, and this is positive. Now, how could we possibly do that? Well, the key to this one, and this one was really a little tricky here, is to multiply everything in this last equation by a negative 1, which would change these two signs and then change this sign. But this is unusual because usually they want the A term positive. So if you had this on your blue sheet, again, you're putting this into the computer and not picking out multiple choice answers, you probably would have done this one. But if you ended up with something like this, that is correct as well. Okay, let's go on here. We want to find a line now that has these points, and we're wondering what the slope would be. So we'd use the slope formula for this. M equals y sub 2, which is a negative 6, minus y sub 1, which is a negative 4, minus a minus makes this a positive, and then a negative 1, minus makes this a plus, a 6. So this is going to be a negative 2, and this is going to be 5. So our slope then is a negative 2/5. Now in some cases they might have asked, what would the equation then of this line be? Well, we now have the slope. We could then use that formula above. And let's spend a moment working on this. And we have a slope then of a negative 2/5. Let's get some room. And I'm going to use the other formula that our book suggests to find the equation. And we want this equation to be in y equals mx plus b. That is slope-intercept form. So we know our slope is a negative 2/5. And we want to find out what our b is here. Now we know our x, and we'll use this one here. Our x is a negative 1. And our y is a negative 6. So we're using this formula, putting in our y value, our x value, and our slope, and we're looking to find out what our new b would become. Well, in something like this, I would get rid of our fractions by multiplying everything by the common denominator here, 5. So here the 5's would cancel out, and I will erase them here now to make it a little simpler here. So in solving this now, this is going to be a negative 30. This is going to be a positive 2. And this is going to be a 5b. So we transpose the 2, becomes a negative 32 on this side. This on this side are subtract 2, and 5b. Now divide everything by 5, and we get our new b value as, oh, I thought I had an eraser. There it is this. So our equation for this line, even though they didn't ask for it in this case, would be y equals a negative 2/5 x minus 32/5. And if they wanted us to put that in standard form, we'd multiply through by 5, take this x term, move it over to the other side. Okay, let's raise it up a little bit. Now, for this one, we can do it actually by inspection. What's our y-intercept? 4. All right, so this one's out because this one's a negative 4. This is a positive 4. So that one's in the, this is a positive 4. And this one down here is a negative 4. So we have a positive 4 here and here. Now, what is our slope? It's 5/1. It's positive. Well, this one's negative slope. This one is positive slope. So over 1 up 5. This is our answer. Okay, that was by inspection. Now, for number 15, they're telling us they want a horizontal line. So this is going to be a y equals b. And then what is our b value in this ordered pair? Well, it's a -7. So y equals -7 is our horizontal line through this ordered pair. Now, what is the slope? Well, for this one, we have to figure out the slope as we did before. So this would be 4 minus a -7 makes it a +7. And this is a -6. Minus a -9 makes it a +9. So here our numerator is 11, and this is going to be 3. So 11/3 is letter D. Now here we want a vertical line through this. Now vertical lines are x equals a. And what is our a value here? Well, it's 3. So it'll be x equals 3. Now, knowing some of these basic equations are very useful. And maybe we'll summarize them here shortly. In fact, yes, let's do it now. As just a little review. And we did this a number of times already in class. But let's do it one more time. So we have ax plus by equals c. Standard form. Y equals mx plus b. Slope-intercept form. Then we had the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Then we had the point slope form. I was going to write out the word, but I don't want that. Now we wrote that above, but we're just doing some review now. y minus y sub 1 equals m times parenthesis x minus x sub 1. Then we had horizontal lines, y equals b, vertical lines, x equals a. And the slope of this, recall, was 0, and the slope of a vertical line was undefined. All right, a quick review, and you might go back and study your formula sheet that we gave you. Many good things there. Okay, jumping on to 18 now. We only have 10 more to do. Is this a solution for this system of linear equations? Well, we have to plug it in. 4 minus 3 equals 1. And yes, that checks. And how about this one? 4 minus a minus 3 equals 7. Just plugging in our values. Well, here two negatives make a positive. So they work in this. So this is a solution for this system of linear equations. Now, for number 19, they're asking us to solve using the elimination method. Now, I don't have a lot of room here, so I'm going to write this up on another page for you. So I've just written these up here, and this is a 7 here. Okay, so by inspection, you see if we multiplied this set of equations here, or these terms in this equation by a negative 1, it would change all the signs. So let's just make that a negative, make this a negative, and make this a negative. So I would end up here then with a 5x. These would then cancel out, and then this would equal, and this one is a 44 here. So this would then be a negative 30, because this is a negative 44. Okay, so we'll just divide by 5, and this is a negative 30 here. And we get x then equals negative 6. Well, if x equals negative 6, we can put it in either equation. The original one, this was 2 times 6 plus 4y equals 44. And this is a 12, so I'm going to subtract 12 from this, and I get 4y equals, subtract 12, let me see here. So, looking at this, let me clear it up. There we go. Be careful of the signs. This is a negative 6. That's what we said here. So this is going to be negative 12. When we bring it over to this other side, it becomes a positive 12, and 44 gives us a 56. There, that's better. We divide both sides by 4, and we get y equals 14. So the ordered pair of this, and again, this took me a little time and I had to work on it, and be careful of the signs, is a negative 6 and a 14. So with that in mind, let's just check this out now. And we are at this one. So negative 6 and 14. And let me clear it up here. Negative 6 and 14 is letter B. Okay, I'm going to do the same thing with number 20 because we're going to use substitution here. And again, there's not a lot of work, and hope it's not too confusing here. Okay, looking at this next example, here were our original equations. This is in standard form, and here we've solved this equation for x. But we're going to take this x value, negative 2y, and put it where the x is, which is what I've done. So I'm multiplying through here. I get a negative 6x. That should be a y there. Pardon me. I'll change that. There we go. So this gives us an negative 11y equals 11. Divide both sides by a negative 11. That gives us a negative 1. So our y here is a negative 1. And then we put it in this equation, and we get x, negative 2 times negative 1 is 2. So our ordered pair is 2, comma, negative 1. And remember, order is significant here. So it has to be that particular one. So you can go back. I'm going to clear this up here so we can see what it looks like here. There we go. I must have did something there. Let's see. Oh, all right, there we are. All right, so that answer is letter A. Let me pause. These take time, and we're on number 21 now. And they're asking us to solve this system of equations by the elimination method. So there they are, and I'll get this set up on the next page.